All right, picking up on problem 13, we have the graph of the function f shown here, has a vertical tangent at the point 2, 0, and horizontal tangents at 1, -1, and 3, 1. So for what values of x from -2 to 4 is f not differentiable? Okay, so it's definitely not going to be differentiable when it's not continuous. It's not going to be differentiable at 0, because you can see it has a jump here as a jump discontinuity. It's also not going to be differentiable where it has a vertical tangent, which is going to be at 2. So we have the point 0 and 2. So the answer is B. All right, problem 14. A particle moves along the x-axis so that its position at time t so that its position at time t is given by x of t equals t squared minus 6t plus 5. For what value of t is the velocity of the particle 0? Okay, so this is the position equation. So let's remember that velocity is a derivative of position. So x prime of t is the velocity, which is going to be 2t minus 6. So then all we have to do is set this equal to 0. You solve for t, and you'll get t is 3. And then that's it. Yeah, our answer is going to be C. Our problem 14, we have our problem 15. If large f of x equals the integral from 0 to x of the square root of t cubed plus 1, then large f prime of 2 is equal to... Okay, so this is essentially using the fundamental theorem of calculus part 2, the second component, where we have to remember that if you differentiate an integration, or if you take the derivative of an integral, you're just undoing the integral. So then f prime of just x would be this. Now, since we're taking f prime of 2, we just plug in 2 into there, and we get essentially the square root of 2 cubed plus 1, or the square root of 9, which will be 3. So the answer is D. All right, problem 16. We have if f of x equals the sine of e to the negative x, then f prime of x is... So this, you just have to remember the chain rule. So we're going to take the derivative of the inside and multiplied by the derivative of the outside. So the derivative of e to the negative x is negative e to the negative x, and the derivative of the sine function is the cosine function. So that times the cosine of negative e to the x. And then that's just going to be E. All right, problem 17. We have that the graph of a twice differentiable function f is shown in the figure above. Which of the following is true? So it looks like we have to study let's study what f of 1 is, f prime of 1 is, and then f double prime of 1. So first off, f of 1 is 0, because this is the point 1, 0. Now, f prime of 1, we know it's going to be positive because it's increasing. The slope of a tangent line is positive. So we know it's a positive number. And then f double prime of 1, see how it's concave down? Since it's concave down, we know the second derivative is negative. And so then we would have that this is the smallest value, then f of 1 is in the middle, and f prime of 1 is the largest. So looking in order, we would have D. Our answer would be D. All right, 18, an equation of a line tangent to the graph of y equals x plus the cosine of x at the point 0, 1 is. Okay, so using the linear equation, y equals mx plus b. Remember, the slope at a particular point is just the value of the derivative of that point. So we need to find y prime of 1. So y prime is going to be 1 minus the sine of x. So y prime of 1 will just be 1 minus, or sorry, we're looking at the y prime of 0. Whoops. Y prime of 0 is going to be 1 minus the sine of 0. Sine of 0 is just 0, so then it'll just be 1. So then, so far, then we know our equation is going to be y equals 1x plus b. Now we solve for b by knowing that it goes through the point 0, 1. So plugging 1 in for y and then 0 in for x. We solve for b, then b is just going to be 1. Then our equation will just be 1, or y equals 1x plus 1. And so the answer is going to be B. Problem 19, if f double prime of x is x times x plus 1 times x minus 2 squared, then a graph of f has inflection points when x equals. Okay, so we want to see where the graph changes its sign of the double derivative of. So we want to see where the second derivative changes from positive to negative or from negative to positive. So we study the possible inflection points. In other words, you find where f, let me actually do this work on a separate sheet of paper. So we want to study where the second derivative is 0. And that's going to be potentially at 0, -1, and 2. Then we want to look at the intervals 0, 2, and then -1. We want to see what's happening between there. So then we just essentially can plug in points, like we can plug in maybe -5, -1/2, +1, and then +5. Just points to plug into the second derivative and to see what the sign is. We don't need to go as far as calculating it. We just need to see what the sign is. So the f double prime of x is x times x plus 1. And we can save some work because any number, whether it's positive or negative squared, is going to be a positive number. So we don't have to worry about plugging it into there. So let's plug in -5 into here. So f double prime of -5. That'll be a negative times a negative times a positive, which is going to give us positive. So we know it's positive in this region. Let me divide this a little better. It's positive here. Let's look at f double prime of -1/2. So a negative and a negative again. And a positive will make a positive. So it's still positive. So there's no inflection point at -1. Now let's plug in 1. F double prime of 1. Positive times a positive. And then, hold on a second. I think I made a mistake. Oh yeah, I did make a mistake. Sorry. F double prime of -1/2. When you plug in -1/2 into this one, you'll get a positive. So a negative times a positive times a positive. This will be a negative. So let's write negative. So there is an inflection point at -1. Plugging 1 in, we'll get 1, a positive, and a positive, and a positive. So we get a positive here. So there is an inflection point also at 0. So far, -1, 0. And let's check to see if there's one at 2. So we plug in 5. Positive, positive, positive. So we get a positive. So there's no inflection point there. So the answers would be at -1 and 0. And so then it would be C. right, problem 20. What are all the values for k for which the integral of x squared is equal to 0, starting from -3? So, well, let's draw a little sketch of the graph. Remember the equation y equals x squared is just a parabola. So, at -3, so something like that, it would be 0 when this area could cancel out with area below the graph, but the graph of y equals x squared is always positive. So the only value that's going to be 0 at is if it integrates just to itself, which is basically because there's no area. So this would only be when it would be from -3 to 3, because you're essentially, again, finding the area of nothing. Yeah, so then it would just be A. All right, in problem 21, we have if more space. If dy dt equals ky and k is a non-zero constant, then y could be. So remember integrating this. If you can remember off the top of your head what the answer, what the form is, that'll save you some time. Let me just walk you guys through it. This will be a differential equation using separation of variables. So we would have 1 over y dy is equal to integral of dt. Integrating this, we would get the natural log of the absolute value of y is equal to t plus some constant called c1. Now, using exponential, because remember this is a base, we would take e to the t plus c1, and that will be equal to y. Oh, I forgot, and it's actually ky. So throwing this back into here, we can do k dt, and this will be kt. Let's see, the constant doesn't matter because it's just a constant times a constant, which gives you a constant. So then we would get e to the kt plus c1 using, remember, properties of exponents. We have, this is the same as y equals e to the kt times e to the c1. Now, e to the c1 is just another constant. So that's just, we can just call this a. That's usually what most textbooks will use. So this is just a coefficient. So this is the same as a times e to the kt. And that constant could be, 2, I guess, because that would be the closest. But that'll be the only one that would match this one. So the answer would be B. All right, so I'm gonna take a break. Let me have any feedback or questions in the comments section if there's anything you are wondering about or anything I didn't explain that well. And if you found this helpful, yeah, be sure to give me a like and make sure to subscribe. And I'll see you guys in the next video where I'm going to finish the multiple choice section.